Welcome Foundations 30 to our video recordings. This is the first one that I have posted, and it will, I guess, finish off our chapter 3. So we'll look at 3.5. 3.5 and 3.6 are very closely connected, and actually they actually make up a different outcome than the remainder of chapter 3. So 3.1 to 3.4 is one outcome on set theory and organization of different elements, Venn diagrams. 3.5 and 3.6 is a bit of a shift, and the outcome talks about reasoning. So a lot of math has to do with the way we think about things, the way we organize things even in our heads and process things, and how we use logic and different things to solve puzzles and come to conclusions. And so in 3.5 and 3.6, we're looking at kind of some of the basics in that, and how we structure things, what we call different things in terms of statements, and yeah, the wording of different ideas. So to start off here, conditional statements. We're going to talk about conditional statements to begin. A condition, you think about a condition, it involves that idea of an if. So a condition and a conditional statement is an if-then statement. And so we see the example right here. There's an if and a then. So if it is Monday, then it is a school day. And in these times, some of these Mondays won't technically be school days, but you get the idea. So the way that we call these, we just using some abbreviations or symbols for these here. We have our hypothesis, and that should be, this is a typo here, should be an I there, but a hypothesis and a conclusion. So P and Q. And so one way you could see it is if P, then Q. So if this certain hypothesis is true, then there's a conclusion that follows. And so we could say that a conditional statement, like it says in this last point here, is either true or false. So we have a true statement or a false statement, and some will be false. And just to illustrate hypothesis and conclusion. So, looking at a hypothesis, and we're familiar with that word. We're familiar with that word from science, perhaps. So when we talk about a hypothesis, it's an idea or a theory based on some evidence, perhaps. And here it says an assumption, but it's what follows the if. So if this hypothesis is true, then there's a conclusion. And so that's this other part over here, which is the result, we could say. So moving on, if you have what's called a counterexample, then it would prove a conditional statement false. So, for example, and I mentioned this example right here, is that if you have that statement, if it is Monday, then it is a school day. So that's a conditional statement. A counterexample to that would be, well, Thanksgiving Monday is the example I have on here, but even Monday, March 23rd or whatever next Monday is, right? It's not technically a school day. We're not sure really what it is these days. But we have these counterexamples, right, where technically it's not a school day, right? A Thanksgiving Monday is a stat holiday. That's a counterexample to that conditional statement. And so the conditional statement is false then, because there's a counterexample. And that's what it says in this last point here. Only one counterexample is needed to disprove a statement. So that's a false statement because we have a counterexample. Now, in order to, again, to categorize things and look at these statements different ways, coming from different angles, there's what's called a converse. And so that's where we switch the hypothesis and the conclusion. And so, again, we have an example here where we switch the order of saying it. So if it is a school day, then it is a Monday. And you notice the hypothesis and conclusion have now switched around. Okay, that statement makes even less sense than the first one because we can find 4 counterexamples, right? Tuesday, Wednesday, Thursday, Friday. So that doesn't make a lot of sense, but that's the way that a converse works. It's the conditional statement, the original statement, where the hypothesis and conclusion are switched. So a biconditional statement is one that is true both ways. So you have your conditional statement that's true. So a conditional statement is true, and the converse is true as well. So if you say it the original way or the way that it's presented to you or straightforward, that's true. But then if you flip it around, it's true as well as the converse. And so I have an example down here. A number is even if it is divisible by 2. And there's actually this phrase that's used in math and some of these reasoning things.
Tracy Funk, please come to the main office. Tracy Funk to the main office.
Anyway, there's this phrase, if and only if, that's used with these biconditional statements. So if it is true both ways, and we'll talk about this statement with that in mind, then we use this phrase, if and only if. So the conditional statement may have been here with this, if a number is even, this will be the conditional statement, then it is divisible by 2. If a number is even, then it is divisible by 2. That's the conditional statement. And if you take the converse of that, remember the converse is just where we switch the last part with the first part, the conclusion with the hypothesis. And so we'll look at that. This is the converse here. If a number is divisible by 2, then it is even. This is the converse of that conditional statement. Now we notice that both of these statements are true. Both are true because we can't find a counterexample, and we know what even numbers are, right? The very definition of an even number is that it has a factor of 2, or that it's divisible by 2. So no matter which way you look at it, either the conditional statement or the converse, both of these are true. So this is a biconditional statement, is what we can classify it as. And then we would say it like this. A number is even if and only if it is divisible by 2. So that could be that would be the way that the biconditional statement is. If the conditional statement is true and the converse is true, then we can write it as a biconditional statement with the if and only if wording. So looking at our first example here, where we're given a different example, a different statement, conditional statement. If Sally is at the Bez, then she is in Saskatoon. So we know it's a conditional statement because it's an if-then statement. It says write the hypothesis and the conclusion. Well, the hypothesis is the beginning part of that statement, not including the if. So Sally is at the Bezboro. That's the hypothesis. Then the conclusion is the last part of the statement, after the then. She is in Saskatoon. So identifying the different pieces of that statement is important, partially because then we can write the converse. So the next part of the question says, what's the converse, or write the converse statement. So the conditional statement is given to us here at the top. And so all we're going to do for the converse is actually switch that around. So we're going to write if, and then the conclusion of the previous statement is now going to be our hypothesis. So if, and let's say Sally, if Sally is in Saskatoon, so there's the conclusion of the previous, now it's our hypothesis. So there's that conclusion, writing it now as our hypothesis. Then she is at the Besborough. So we see the hypothesis of the original, the conditional statement, is now the conclusion of the converse. The conclusion of the conditional statement is now the hypothesis of the converse. The second part of that question is the statement biconditional? And so remember, we're looking to see if it's true both ways. Is this initial one up here, is this true? And is this true? Okay? I think we can agree that the first statement, if Sally's at the Besborough, then she's in Saskatoon. That's true. So let's just write here, the conditional statement is true. Okay, the converse though, let's think about this converse. Yeah, you have to stay past the bell today. So this is our converse right here. Is that true? Well, if she's in Saskatoon, then she is not necessarily at the Besborough, right? So what's a counterexample? And that's even mentioned in the example or in the question here. What's a counterexample to that? Well, wherever you are right now. If you're in Saskatoon, maybe at your house, or if me right now, I'm recording this at the school. I'm in Saskatoon, so Sally could be at any number of those locations. Those are all counterexamples. So we'll mention one of them after we write down the fact that the converse is false. So the converse is false. And then a counterexample to that. She could be at Midtown, let's say. Close to the Bez, I guess, but not at the Besborough. So the converse is false, which means it is not biconditional. The statement is not biconditional. Try to squeeze that in here. So, dealing with the biconditional statements. The last thing to finish up here in 3.5 is just you kind of bringing it back to Venn diagrams, or seeing how Venn diagrams can work themselves in here. You might say that if you have a true statement, that P, your hypothesis, is inside in the subset of Q, or is a subset of Q. For instance, if we're talking about the Bez in Saskatoon, right? If Sally is at the Bez, then she is in Saskatoon, right? That makes sense with that. Whereas if we flip that around and had the conclusion a part of as a subset of the hypothesis, in this case, it doesn't make sense. So there won't be a lot that we talk about with Venn diagrams here, but there is a little connection that can be made to that. So the main takeaways from this 3.5 are just what a conditional statement is. Let's go back to that as an if-then statement. Okay, so that's a takeaway. And then what the different parts of that are: the hypothesis and the conclusion. And then what does it mean to be take the converse of the statement? And then when a statement would be biconditional. So when the conditional statement and the converse are both true. So definitely a lot more word-based here. There's not a lot of actual like number and calculation work that we're doing here, but there's a lot of organization and kind of foundational math thinking ideas that we're touching on here. So I'll provide some textbook questions for you to work on some of these ideas. Let me know if you have any questions with the notes here in the recording, or if you have any questions about the textbook things that you're looking at. 3.6 will be very similar to this, and I'll post that shortly.